How has it been the past 1 week in school? Normal? Is it tiring because you have just started to take on more subjects, trying to get used to the system and the more subject thing, right? Yeah. Okay, so just move on with confidence. At any point of the time, it's not just for chemistry, any other subjects, if they have questions, you have to clarify immediately. Right? Try not to accumulate because you start to feel very stressful if it starts to accumulate. Right? All right, we're going to take a look at this question. All right, I'll give you the answers for question 1, 2, and 3. So question 1 is B. Question 2 is D. All right, question 3 is also a D. All right, so it's B, D, D. Now, first of all, let's look at the question 1. All right, a bit of points to highlight here. Now, the chlorine gas is actually a colored gas. You will be learning this, this concept in the topic on periodic table. So chlorine is a halogen, right? And it's yellowish green in color. Now, on the other hand, nitrogen gas is an inert gas. Okay, so why is it that nitrogen gas is an inert gas? Okay, let's go a bit into the concept for this as well, because you're going to learn about the dot cross diagram, the covalent bonding for and ionic bonding in the next chapter. All right, so if you look at the nitrogen N2, oh, by the way, have you learned how to draw the dot cross diagram before in Sec 1 and 2? Yes, no, okay, no worry. Now, nitrogen has triple bond. In each pair of nitrogen atoms, there will always have this triple covalent bond. Now, why is that so? It's because nitrogen, which group is nitrogen in? Do you have a periodic table? Okay, give you a copy of periodic table. Okay, there you go. Could you pass it to them? Thank you. All right, so if you were to look at this nitrogen, it has a total of 5 valence electrons, right? Because it is in group 5. Okay, so we're going to put the valence electrons on the outermost shell. Now, is it a stable configuration? No, it's not stable. Now, in order for it to have a stable configuration, it needs to have a total of 8 electrons on the outer shell. So what does one nitrogen atoms do? One nitrogen atoms will therefore share a pair of electrons, in fact, a total of 3 pairs of electrons with its counterparts, so that each of them will now have a total of 8 electrons. You see, if you look at the first nitrogen atoms, we have 1, 2, 3, 4, 5, 6, 7, 8. Right? Same for the second nitrogen atoms, there are also 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, Ethan haven't learned this, right? Yes, no worry. When you go into the topic on chemical bonding, you'll be learning on how to draw the dot cross diagram for nitrogen. All right, so if you look at this nitrogen here, both of them are very stable. So they will come together as a pair of atoms to form a stable molecule, which is why when we write the formula for nitrogen gas, we will often write it as N2. N2. So this triple bond here indicates that it has shared 3 pairs of electrons with its counterparts. Got it? Okay, so no worry, we'll go into that chapter soon. But for this question, why is the answer B? Because when they remove the separation right, between these two gas jars, you will see that the chlorine gas and the nitrogen gas, which are both gases, will definitely be moving in random motion, random direction. So eventually they will be mixed together evenly. All right, so B is the answer. Any question? No, okay. What about question 2 and 3? Do you need me to go through or you got both right? Sorry, question 2, okay, sure. Now question 2, distilled water, H2O. Now in order to do these questions, you must know what are the particles that are involved in each of the solution. Now, what about potassium manganate 7 solution? Now, potassium manganate 7 solution has this chemical formula KMnO4. Right, and then this solution is made up of K plus ion and the MnO4 minus ions. So what is a K plus ion? K plus ion is known as potassium ion. Right, the potassium ion. And then the MnO4 minus is known as the manganate. Right, manganate 7 ions. All right, so which is why when you put all this as a mixture, it will not only have the water molecules, all right, it will also have the potassium ions and the manganate 7 ions. Now, why is it that the potassium manganate compound or the solution cannot exist as molecules? Because this is an ionic compound, right? It's an ionic compound. So being an ionic compound, when it dissolves in water, it will turn into the ions. That means it will dissociate into ions, right? So when you go on to the chapter on chemical bonding again, you will see that some of this ionic salt, for example, the sodium chloride salt, you know, the table salt they've been using, right? You dissolve it in water, it turns into a salt solution. So sodium chloride dissolves in water. In the water itself, right, it doesn't exist as NaCl anymore, but exists as a mixture of the sodium ion and the chloride ions, right? So this is only true for ionic compounds that are soluble in water. Got it? Zachary, all right? Yeah, okay. So that's why we have the answers D. Can Ethan? All right, take it as it is first. I know you have not learned about potassium manganate or anything like that. You don't even know about the color. But when you move on to the other chapters, you will be able to learn that the potassium manganate solution is actually a purple solution. All right, so eventually when it's mixed with the water, you will get a light purple solution as a mixture. All right. Okay, and I'm sure for 3 should be okay, right? You just have to calculate the MR of each of the molecules. So if you look at the nitrogen dioxide, we said that this has an MR of, Ethan, what's the MR of nitrogen dioxide? 40. And just sum up. By the way, what's the formula for nitrogen dioxide? Any idea? You know what is the formula for carbon dioxide? Correct, CO2. So with nitrogen dioxide, it will be NO2. All right, just changed it to nitrogen. All right, so with nitrogen dioxide, you have an MR of? Correct, very good, 46. Carbon dioxide is 44. Hydrogen gas is H2, so it has an MR of 2. All right, so you can see hydrogen gas is the lightest, nitrogen dioxide is the heaviest, so nitrogen dioxide diffuses the slowest. All right, okay, steady, no problem. Okay, let's go on to, now question 4 is pretty easy. I'll read out to you the answers. The first one is sublime. Second one, part B, breaks the bond. Part C, evaporate. Part D, condense. And then part E, fixed volume. Right, fixed volume. Okay, now I'll be going through very quickly question 5 and 6 as well before we go into question 7 onwards. Now question 7 to the question 10 are the examples of the structured questions that I want to use to explain to you on the standard template that you can use for answering such a question. All right, so very quickly, 5, F to E, Zachary, answers. is this? What's the physical state of the substance from F to E?
Solid.
Ooh, solid.
Okay.
Yes, it's a gas. All right. Why is it a gas? Because this is a cooling curve. A cooling curve will show you how a gas will be condensed into a liquid, and then from a liquid it solidifies into a solid, right? Due to the decreasing temperature over the time. All right, so F to E should be gas. What about E to D? What is that process called? Correct, condensation. And during condensation, there'll be a mixture of the gaseous and the liquid state. So gas and liquid are temperature for which one? Good question. Now, in any change of states, right, the temperature, in this case, the temperature does not decrease, or in fact, it remains constant, is because during the change of states, the energy is used to form back the intermolecular forces between the particles so that the liquid particles can come closer together. So that the gaseous particles can come closer together and get it into the liquid state. All right, so it's due to the energy being released to the surrounding by forming back the forces of attraction. All right, the energy is not used to increase or decrease the temperature. Does it make sense? Okay, so since you have asked about this, let's draft out a template. Why temperature remains constant during condensation or solidification processes. Alright, so first of all, they say that during these processes, energy is lost to the surrounding. You can see that energy is gained because the temperature is decreasing, right? So there's loss of energy to the surrounding. And the energy is lost to the surrounding due to the formation of the attractive forces between the particles. Right, the energy is lost to the surrounding is due to the formation of the attractive forces between the particles. It's not due to the drop in the temperature. Got it? So by right, if let's say there's a decrease in the temperature, energy is being lost to the surrounding, right? In what kind of energy are we looking at? Heat energy. Agree or not? But not in the situation where there's a change of the physical states. Got it? Okay, so once the condensation or the solidification processes are completed, right? And then if you continue to decrease the temperature, energy will continue to be lost to the surrounding. The temperature will start to decrease. Get the idea? Okay, good. So conversely, if you see such a question, why? Okay, let me copy and paste, be faster. Oh, why can't I copy and paste? I thought I could do it. Thanks. I tried. Does it work? Okay, good. Yes. So I think you're young people, very tech savvy. I'm not saying that old lah. Also, I'm also not very old, but at least you're younger than me. Okay, next time I'll try that. Okay, so why does temperature remain constant during melting or boiling processes? Control C, Control V. All right. Okay, so now you're going to answer it in the reverse way. Now, during melting and boiling processes, temperature remains constant, right? It's because energy is absorbed to break the forces of attraction. All right, so imagine when the solid were to be turned into the liquid state. That's melting, right? How come in the liquid state, the particles are now further apart as compared to that in the solid state? It's because the forces of attraction have been broken between those particles in the solid state, making the particles in the liquid state to be slightly further apart. And the energy is absorbed to do that. The energy is not being absorbed to increase the temperature. You got the idea? Right, so here we're going to say that energy is absorbed from the surrounding to overcome the forces or the attractive forces between the particles. You can even further explain what happened during melting. So during melting, the particles are now further apart as compared to that in the solid state. So during melting, the particles are now further apart as compared to that in the solid state. Turning solid into, got it? So with this template, you can just change the subject accordingly. And if you see this kind of questions, you can use this as a template. Get the idea now? All right. Any questions? All right, and lastly, for the stage at D to C, that's definitely a liquid. All right, so that's the answer. Okay, what about part B? What do you think is the freezing point of the substance? Doesn't really shown on the picture, right? Should we skip this question because it's not shown in the picture? Answer key shows 44 degrees Celsius, but it doesn't really show. But if you see such a question, right, what will they do is that they will indicate to you the melting point as well as the boiling point. So in a cooling curve, the higher temperature that remains constant is always the boiling point, all right, or we can say that it's the temperature where the condensation is taking place, and the temperature at the lower, as in the next temperature that remains constant, right, and lower value will be the melting point or the solidification temperature. All right, so take note on this. That's for cooling curve. Any questions, guys? No. Guys agree? All right, but part C is important. How would you describe the movement of the particles when it moves from B to A? Can I clear all this writings? Can I? All right. Okay, so if you're asked to explain, if you look at this B to A, we know that this is the solid state, right? So how do we explain about the movement of the particles? So simply says that From B to A, the particles can only vibrate in their fixed positions. As the temperature is decreasing. As the temperature is decreasing. So you're asking you for the movement, you just have to indicate the movement. You don't have to highlight about the arrangement or any other points. All right. Okay, let's move on to question 6. All right, question 6, part A. So I'm going to give answers on the spot. So which one is water? This one should be very easy. You can see that E is definitely the water because water has a melting point of 0 degrees Celsius and boiling point of 100 degrees Celsius. All right, so what about the volatile liquid? All right, volatile liquid. Now, what do you mean volatile? Volatile refers to a substance that has very low boiling point. So it will undergo evaporation readily. All right, it can evaporate and turn into gaseous state very easily. So if you look at the option A, can you see that the melting point is very low? Boiling point is also pretty low, 68 degrees Celsius. Well, 68 degrees Celsius is not a very hot temperature, right? Yeah. So it will be a volatile liquid at this boiling point. So A is the answer. Okay, now what about C? Substance that's likely to be an iron. Iron is a metal. We said that metal has very high melting point and boiling point. So you should assign C to it. All right, then what about gas at room temperature? Your turn to try. Zachary, what is your answer? How do we tell which is a gas under room temperature and pressure? And what is room temperature and pressure? Now, room temperature and pressure is taken as 25 degrees Celsius for reference. Yes, it's D because its boiling point is negative 78 degrees Celsius. That's way below the room temperature. So at room temperature, it will already exist as gas. Can? Ethan, okay, right? This kind of question. Okay, good. Then what about part E? Substance that is a solid that will melt easily when heat is applied. Ethan, what's your answer? Yes, right. Okay, this B, because the melting point is 69, you apply a little bit of heat, it will start to turn into the liquid state. All right. Okay, I will need you to take a look at question 7. Very quickly read through the questions because I'm going to use these questions as an example to show you how to put it in the proper template when answering such a question. Both of you are getting ready to answer part A. Yeah? I think part A is pretty straightforward. So what is X? Exactly. At room temperature and pressure, which is 25 degrees Celsius, X will be a that's right, okay, gas. Y, Ethan, the answer? Solid, correct. Hence, Z will be a liquid. Alright, so let's talk about why. Why is it that it is a solid? Because its melting point is above the room temperature and pressure. So at 25 degrees Celsius, it will exist as solid. Or however, if you increase the temperature beyond 45 degrees Celsius and above, it will turn into a liquid and slowly into the gaseous state. All right, simple. Part B. So if we have all the three substances in a solid state, which of the processes will occur to each substance when you expose them to the room temperature? This is interesting. So assuming that they are all in the solid state, right? They are all in a solid state. When we expose them to the room temperature and pressure, which of these processes will occur? So you will have to explain what happened if I put X into the at room temperature. Now, can you see that X will melt? What is X? Okay, X will melt and then boil. Agree? All right, it will melt and then boil. Why? Because the room temperature is much higher than the melting point and the boiling point. Oh, because if you look at the melting point and boiling point, right, it's way below 25 degrees Celsius. So they are saying that doesn't it start as a gas, right? Why solid? Oh, correct. So you see that answers your question. So they say that you have to assume that the substance is a solid. But actually at 25 degrees Celsius, it's not a solid anymore. It's a gas. So assuming that it is a solid, what will be the processes that will allow them to turn into that physical state at 25 degrees Celsius? So that's why it melts and then boils, right? Because the room temperature is much higher than the melting point and the boiling point of X. So it will therefore melt first and then boil. Let's look at why. Zachary, what do you think? Correct. Okay, so why will not any change of states? And lastly, Z will melt. Can't you see that Z will melt? Right, because the melting point is 20 degrees Celsius, that's below, just slightly below 25 degrees Celsius. So it will melt. Okay, now part C. If we have a substance Z at 60 degrees Celsius, describe what happens if we were to cool the substance Z from 60 to 10 degrees Celsius. Now, such a question is quite commonly asked for this kinetic particle theory. So you have to organize your answers and explain at each stage, at each temperature, what will happen to the particles. Now, sometimes they may even want you to describe about the arrangement of the particles and also the movements of the particles. So can you see that for Z at 60 degrees Celsius, that's in between 20 and 80, right? First, you're going to tell the examiner, what is the physical state that Z exists as at 60 degrees Celsius? You all agree that it is a liquid? Right, Z is actually a liquid, right? So when we decrease the temperature from 60 to 10 degrees Celsius, that means we are changing it from a liquid state and probably to the solid state. Because if you look at the melting point of Z, which is also the solidification temperature of Z, right, is 20 degrees Celsius. But we're going to bring the temperature all the way down to 10 degrees Celsius, which is below 20 degrees Celsius. So you should expect solidification to take place. Make sense or not? Okay. So in each stage, you have to explain. First of all, indicate that Z is a liquid at 60 degrees Celsius. Right? So when we decreasing, or when we decrease the temperature, sorry, when we decrease the temperature, what will happen? When we decrease the temperature, yeah, okay, so when we decrease the temperature, the particles, I'm still going to explain about the behavior of the particles. The particles in the liquid Z will slow down and come closer together. Now, will slow down means that the liquid Z is actually losing its energy, right? Losing the energy. So they come closer together. Then this will happen until it hits 20 degrees Celsius. Make sense or not? All right. So at 20 degrees Celsius, particles are so close that they can form the forces of attraction. Close to one another that they can form the forces of attraction. And solidification. Okay, so changing it to the solid state and solidification happens, but that is only referring to the changes that happens at 20 degrees Celsius. But the question wants you to explain further to the 10 degrees Celsius. All right. Okay, so at 10 degrees Celsius, temperature will still continue to drop, right? Okay, so we're going to say that at 10 degrees Celsius, the say the particles remain in the solid state. Celsius. Right, so during melting and any changes of that, the change of states, right, you have to explain it in this template. Talk about what happened to the particles, right? So Just a summary, if it's melting, boiling, you're going to say that the energy has been absorbed to overcome the forces of attraction. If it's condensation and solidification, you should say that the energy is being released to form back the forces of attraction between the particles before you make a conclusion in saying what happened to the change in the physical state. Yes. Oh, yeah, of course. For these questions, you have to. Yeah, so that will also be another changing factors. You cannot give a very generic one. You got to answer to the questions precisely. So they have already specified to you that you got to describe the changes that happens from from 60 to 10, right? So you got to describe all the temperature. I'm going to mention about temperature. All right? Is it Hank? Okay, Ken? All right. Any questions? This question. All right, so anyway, got this. Let me clear the drawings. Okay, now question 8, I'm going to leave it to you to do it because that involves the graph plotting. So go and try it on a graph paper, bring it in the next week. Okay, we shall go through this. All right, now what about question 9 and 10? So a standard template. First of all, question 9 it shows a glass tube, or a glass tube, and it's soaked in the concentrated aqueous ammonia at one end and a cotton wool with this concentrated hydrochloric acid at the other end. So after some time, a white solid was formed somewhere near the tube, right? Have we done this question last week? We didn't, but we did a similar one, right, in the MCQ. So I want to use this example to show the template again on how to answer such a structured questions. Okay, before I go into that, let's run through the reaction. Remember we talked about the neutralization reaction last week with respect to this question. So we have ammonia. This is the formula for ammonia, NH3. We're going to add it in with HCl. Now it will form the ammonium chloride, NH4Cl. NH4Cl. Now this ammonium chloride is actually the white solid. And do you remember what is the nature of the ammonium chloride? Yes, could you remember that? What's so special about ammonium chloride? Okay, so ammonium chloride is a substance that will sublime, right? Yes, okay, now we said that under room temperature and pressure, it is a solid. But if you heat it up, it will turn into the gaseous state easily. In fact, if you heat it further, it will change into the ammonia gas and also the hydrogen chloride gas. So in other words, this reaction is reversible. Got it? Okay, so it sublimes. Now that is the chemistry or the chemical reaction for this compound between the ammonium, the aqueous ammonia and the concentrated hydrochloric acid. And that also explained in part A, how is it formed? So it is formed when the ammonia reacts with the hydrochloric acid to form the ammonium chloride. So in part B, right, part B, so which part of the, or which position would the solid form be, a solid white, as in white solid will be formed? So within that, it should be at, agree? X, Y, or Z? Correct, okay, X. Now, it will be formed at X because hydrogen chloride is heavier than that of ammonia. So it will diffuse slower as compared to ammonia, right? So by then, when ammonia comes in contact with the hydrogen chloride, it should be closer to the to where the hydrogen chloride was. So how to put it down in words? Standard template as well. So first of all, you're going to say that relative molecular mass. Now we can't use the abbreviation MR without indicating the full name for it. All right, so you find that these words are too long. What you can do is you can indicate it as the full name firstly in bracket MR. So that for the subsequent answers or subsequent part of the answers that you're going to explain, right, you can keep using the abbreviation. But you cannot use abbreviation first without telling the examiner what is that abbreviation stand for. Got it? Okay, so relative molecular mass, MR, of the hydrogen chloride, HCl, is, how much is that? 36.5, right? 35.5 plus 1 is 36.5, whereas the MR of NH3 is 17. See, I use the word MR now because I've mentioned what is MR in the first place. Whereas the MR of the ammonia is 17. And diffuses lower as compared to ammonia. The glass. Thus, the two gases will contact turn. To the concentrated HCl. All right. Got it? Okay, and what about part C? So if you were to remove the cotton wool, stopper the tube and apply heat to the white solid, it disappears and the white solid are formed near both ends of the tube. Explain why this happens. So you see, you need to know the sublimation nature of this ammonium chloride, right? So if I were to apply the heat to the white solid, how come it will disappear? Because it sublimes. When you increase the temperature, the ammonium chloride will turn into the gaseous state, turn into the ammonium chloride gaseous state, or the gaseous ammonium chloride. Right, so first you're going to say that the reaction, right, the reaction of what? The reaction between ammonium chloride and the HCl, between the ammonium chloride, ammonia and HCl is reversible. So based on this reaction here, right, you can see that this white solid, if you heat it up, it will turn it back into the gaseous state. As I mentioned just now, it will also be broken down to form your ammonia gas and the hydrogen chloride gas. All right, so upon heating, and turn right into gaseous state. So ends of the tube, it will be cooler, right? Both ends. So when these gases are produced, the ammonia gas and hydrogen peroxide gas are produced, they will start to diffuse towards the ends of the gas tube, right, the glass tube, which are cooler region. So at the cooler region, it will then start to come in contact and form back the ammonium chloride. For which one? Forming back, yes, we have to talk about it because the question says that you start to see white solid form near both ends of the tube. So explain why such a phenomenon happened. All right. You hope to write lesser things, right? Sometimes the questions wants you to write more, so you really have to answer the questions. You may find that the answers are very lengthy, but these are all the compulsory points. So you get used to writing a lot of things when you're doing your sciences. All right. Exactly. I know you take physics and chem. What about you, Ethan? Also take physics and chem. Oh, okay lah. Bio even have more things to write. Yes. Okay. Understand this question? You will see this kind of questions quite commonly asked in your test. Right now, you may not know that ammonia reacts with HCl. You find it very foreign to you, but you will get used to it. These are the classic questions that we ask in the topic of kinetic particle theory. All right. Okay, let me clear my drawings and we'll go through the question 10. Okay, so question 10, the U-tubing question. So what should be the correct way of explaining this? So look at part A. What will happen to the water level at X in the U tube and why? Ethan, would you like to try? Will X be going down or going up? X will go down. Agree? Correct. Okay, so X will decrease. So you have to explain why. So template again. First, you have to indicate that the relative mole length of gas is 32, whereas very standard way of answering this. Whereas m out of faster, oxygen or carbon dioxide? Oxygen, right? Okay. Therefore, oxygen. Now you have to tell the examiner, how will oxygen be diffusing? Is it diffusing out of the pot or into the pot? So obviously it will be diffusing out of the pot, right? Because it's already inside the pot. So you're going to say that, therefore, oxygen diffuses out of then carbon dioxide So first point, mention about the MR of the two gases. Second point, talk about how they move. Haven't finished. The third point, you have to mention that as a result, the gas pressure will be that is as a result, the gas pressure inside the pot will be lower than the outside the pot. Okay, now we call this as the left-hand limb. You see this part here? This is the left-hand limb. This is the right-hand limb. All right, causing the water level at the left-hand limb. If you want to use this also can, then you go and label it as Y or Z or what. Okay. To right and draw. Right, so three main points to be explained in your writing, okay, when you answer the YouTubing questions. So it's very important to bring in the gas pressure because that's where most of the students will miss out the gas pressure part. Any questions, guys? Okay, and the last part of it is what will happen if you place a beaker of the hydrogen gas over the porous pot containing oxygen? What happened to the water level in the U-tube after a while? So because of the word after a while, you have to tell the examiner that after a while it will rise back to its original position. Right? So the immediate change is that the liquid level in the U-tubing will not be the same. But after some time, it will go back to its original position. So what do you think will happen to the water level in the U-tube after a while, Ethan? Any idea? Water level. Mean and X, is it? Good, right? Or will it decrease? Increase, decrease? Yes, increase. Right, so the same thing is because hydrogen gas is actually lighter, so it will diffuse into the pot at a faster rate than the oxygen diffuses out of the pot. So pushing the water level down on the left-hand limb since there's a higher gas pressure inside the pot. Right? Okay, so that's how you should put it first. So it also explain why you can use the same template as you use in the part B. All right, just change the subject accordingly and reverse the words when necessary. Right? Simple, huh? Okay, so this will give you a very comprehensive way of explaining the question for this topic. So use them and stick to this template. Okay, very good. So we are done with this paper. We can go and try question 8, which is the graph questions. Now we have a bit of time. I want to go back to the worksheet 1.1. Right, just try a few more MCQ because I don't think we finished all the remaining MCQ. We have picked a few questions here and there to do last week, but there were quite a number of them that I've not done. Okay, let me clear this, go out. A little slow. Short stop. Okay. Okay. All right, so worksheet 1.1. All right, so let's take a look at this question. Let me see here. Question 8. Okay, look at question 8. I don't think I've gone through that, did we? Not at all, huh? Yeah, okay. We're gonna look at question 8 first. So we have this cover plate that were removed from the gas jar, and then it was seen that after several days, the color of the gas jar will be the same. So what has happened? When we remove the cover plate, right, we allow the two gases to diffuse across one another. So eventually they will have a mixture of these gases, right? So is it correct to say that the oxygen and the chlorine gas will diffuse at the same rate? Do they diffuse at the same rate? They don't, right? Yeah, because they have different relative molecular mass. But what about C? Oxygen and chlorine molecules are in random motion. Okay, so that's the answer. So due to the motion of the particles through diffusion, these two gases molecules can actually diffuse across one another and in random motion. Right, so C is the answer. If we done 7, we have done 4 and 5. Did we do 4 and 5? We have done 5, is it? What about 4? Okay, what's the answer for 4? Okay, this is very simple, right? Diffusion, okay? Yeah. And then what about 1, 2, and 3? Okay, then we look at 1 first. By the way, nitrogen dioxide is a brown gas. Obviously, air is colorless. So what do you think will happen if you were to remove the glass plates? Ethan, what's your answer? Okay, so both the upper glass tube and the lower glass tube will turn brown, right? Yeah, so your answer should be B. Got it? Because of the even mixing of the gas. Okay, let's scroll down. 8 was done. Hey, no, just now we didn't do 6, right? Okay, so 6. Could you remember what is the formula for copper 2 sulfate? I'm sure you have came across copper 2 sulfate in the sec 1 and 2, right? Oh, very good. CuSO4. Wonderful. CuSO4. Now, this is actually an ionic compound. So this CuSO4, copper 2 sulfate, is made up of the copper 2 plus ions as well as the sulfate SO4 2 minus ions. So which means that when it dissolves in water, it will be dissociated. It will be broken up into the Cu2 plus and the sulfate ions together with the water molecules. So that's why the answer for this is C. So it's a similar question as what we've done in the previous worksheet. All right. Okay, move on. Do we do 9? Well, I don't think so. Okay, what is your answer for 9? So obviously the process will be the diffusion. Simple. Okay, diffusion. Remember, diffusion will only happen in the liquid or the gaseous state. All right. Okay, what about 10? We'll stop at 10. What do you think is the answer? Which of the following correctly describes the particles in the dilute sugar solution at room temperature? The key word is dilute. Dilute means what? Does it mean that there's a lot of the sugar molecules or a little bit only? Only a little bit, right? Okay, so sugar molecules as compared to the water molecules are bigger. Why? What is sugar? Sugar is C6H12O6, the glucose. Right, water is only H2O. You see, one molecule of water has how many particles? How many atoms? 3. But the sugar molecules has so many atoms. Obviously, it's bigger, right? Okay, and because it's diluted, it means that there's lesser sugar solution. So with lesser sugar solution, it also means that there are more water molecules than the sugar solution. Do you all agree? So therefore, the sugar molecules will be widely separated, but the water molecules are closer together. Make sense? Okay, so that's why A is the answer. It will definitely be moving because both of them are in the liquid states. All right, it's just that there are only a little bit of the sugar molecules, that's why they are further apart, but they're all packed by the surrounding water molecules. Okay, guys? Yes? Okay, good. So I hope that today's session I've given you a clearer insight on how to answer the structured questions for this topic. So next week, what are we going to do? Ethan, you're still doing this topic, is it? All right. Then what about Zachary? Just now you mentioned that you have moved on to, which is separation technique. Can't remember. Okay, no problem. I will go through the separation technique as the next chapter. All right, but if let's say you are learning other topics, then I will change on the spot. No worry on that. All right. Okay, so no homework because we've done quite a lot of things these 2 lessons. I will see you back for class next Saturday. All right. Okay, good. That's it.